Are you thinking of buying a Tesla? Do you want to learn more about the magic behind Teslas and see how they compare with their competition? In either case, this video is for you. We will start the video by having a look at the current capabilities that the Tesla Autopilot has, which are very impressive. Then we will compare the approach that Tesla is having with their competition, which are other automakers with self-driving capabilities. And there is a key difference. Finally, we will learn about the magic behind Tesla, and we will reveal the key component that's allowing them to have the most advanced autopilot system in the market. Tesla provides various levels of autonomy. The most basic one is the free autopilot, which is included with every Tesla. This includes a set of safety features like red sign and stop sign warning, as well as forward collision detection and blind spot monitoring. The most interesting feature of this free autopilot is that it can keep your lane. So when you are driving and you activate this mode, this free autopilot, what it does is that it's gonna corner and pretty much do everything you have to do when driving. So let's put an example where there is a 90-degree turn ahead of you. What it's gonna do is what you would like an experienced driver to do, which is reduce the speed just before entering into the corner and accelerate back to the desired speed when you're going out of the corner. Aside from this basic form of speed control, it also has a more advanced speed control system where it's going to adapt its speed depending on the traffic. So if there is a car ahead of you and you cannot overtake it, then it's going to match the speed of that car, and when it goes out of the way, then it will accelerate back to wherever your desired speed was. Something interesting to know about this free autopilot is that if you release the steering wheel for more than 30 seconds, the car is going to beep at you and is going to signal that you are responsible for the car, therefore you have to pay attention to the road. Let's move to the interesting part, what Tesla calls the full self-driving. This is going to cost you $12,000 in US and around £7,000 in UK. Among the features, have auto parking is very useful if you are in a parking lot. The car is going to find its own parking space and park itself. Then we also have features like Summon, where you can convert your real life car into a toy by driving it through an app. And a Smart Summon, where by pressing a button you can have the car drive to you, which can be very useful, for example, if it's raining and you don't want to walk wherever your car is parked. But the most interesting part of this full self-driving is that it does everything related to driving in the highway. This includes keeping the lane, changing lane, overcoming slower drivers, pretty much everything. Aside from that, it can also recognize red lights and stop signs. In the case of a stop sign, what it would do is that it's going to go to a full stop, and then you have to press the gas pedal to signal that it's safe to go again. It can also recognize speed signs and set its speed accordingly. If you don't want to do that in the highway, you can set the speed that you desire manually. Let's have a look at Tesla's competitors to better understand what makes them special. The first competitor that we will talk about is GM and Cadillac, which have the same autopilot system. They have quite an original approach, where they have mapped some of the major freeways with a high-resolution LiDAR. And all the vehicles within their fleet can use this high-resolution map in order to navigate autonomously through those US freeways. The second competitors are Volkswagen, Porsche, and Audi, which all fall under the same Autopilot system, and it has been designed for mainly two different situations. The first one being driving on the freeway, and the second one for driving in traffic jams. So you can expect to have some features for lane centering, speed control, matching the speed of the car in front of you, quite similar to the ones that we have seen with the Tesla free autopilot. Other automakers like BMW have a similar set of features as the ones that we just mentioned. What's important to remember of all that is that these automakers all use mainly radars and cameras. But Tesla doesn't use radars, at least doesn't use radars anymore. The first Teslas, they were all equipped with radars, but the new ones aren't. Why is that? Before we answer this question, we need to understand what's a radar and why is it used for. A radar is very good for understanding the distance to different obstacles that we have. And combined with cameras, it can provide the depth of the image that you have. To understand what Tesla has done here, we need to understand a little bit of AI or artificial intelligence, and we need to introduce the concept of a label dataset. A label dataset is simply a dataset that contains the result that we want to obtain. In this case, what we want to obtain or what we want to predict is the depth of an image. And this is provided by the radar. So for all the cameras, we have the depth that came from the radar. That made a huge dataset that Tesla has leveraged to train neural networks, and they have created a model that's able to predict the depth for any image. Therefore, the radar is not required anymore to provide the depth information for the camera. Elon Musk tweeted that when vision and radar disagree, which one do you believe? He said that since vision has a lot more precision, it's better to double down on vision rather than doing sensor fusion. Sensor fusion simply means combining the output of two different sensors, in this case a camera and a radar. If you are interested in Tesla, self-driving cars, or machine learning in general, have a look at my course, where I clearly explain all the key components that make self-driving cars possible. It doesn't require any prior experience, and by the end of it, you will have developed your own fully working self-driving car. Tesla is not only a car manufacturer, but one of the biggest AI and robotic companies in the world. How is Tesla able to drive only with cameras? We already talked about the depth prediction, but that's not everything. In order to better understand that, we need to see a bit of history, and we need to have a look at the previous approaches that they have tried. The one that we're going to talk about is called the Hydra. For all the different cameras, they have a feature extraction pipeline that creates some features that then they are fed to the Hydra. This Hydra has three different heads. The first one is for object detection, so to say there is a car, there is a pedestrian. The second one is for traffic sign monitoring, and the third one for lane prediction, so we can actually drive through the lanes. What was the problem of this approach? The problem is that the detections were made into the image plane, and an image is always a 2D plane. But when we are driving, we are moving into a 3D space. So the projection from the 2D space to the 3D space introduced quite a lot of error, even if the depth prediction of the cameras was quite accurate. The new approach that they took is slightly different, and they kept the same feature extraction pipeline, but instead of processing the different features for each of the different cameras individually, they have grouped them together. They have also used the power of transformers, which are a novel neural network architecture. And by using those, they were able to solve the main problem that they have, which is that now they predict elements into the 3D space directly. And this way, they didn't have to make the projection that was introducing so much error. Another big improvement of the new system has been the addition of memory. This has a lot of different utilities, but a good example is that if, for example, you have seen a car, but then there has been an occlusion or there has been something covering it and you could not detect it, and then you see it later on. By relating those two detections with the use of memory, you can infer some interesting properties, like speed. Other things that have improved as well is the path planning, where by using neural networks they were able to achieve a much better performance and a fit that is more suited for cars compared to other most common algorithms like A-star or RRT-star. The biggest advantage that Tesla has over other competitors is that it has an enormous amount of data. How did they get this data? They use all the vehicles within their fleet to collect data. And all this data is labeled. Remember this concept that we already introduced? And how is it labeled? When the car is being driven by a human, the labels are the steering angle and the gas pedal pressure that we have, so the car is learning how to drive. What about the ones that they are using the full self-driving capabilities? Are they providing information that is valuable for Tesla? Yes. How is that the case? When the car is driving, but you have to stop it, when you have to correct it, that's an invaluable data point because you have shown Tesla where there is a problem with their autopilot system, so they can try to improve it. But there are always situations that aren't captured. And when that's the case, what they do is to simulate it. The main advantage of using simulators is that all the different parameters are known. So the detections are very accurate. But all this training of massive neural networks and a lot of simulations require a lot of computational power. How are they getting it? They are designing their own chip, which is named D1, and they're gonna stack a few of those together to create their own supercomputer, which is gonna be named Dojo. If you think that you or your company can use any of the technologies laid out in this video, but you don't know how, I can do it for you. I'm an experienced data science and consultant who has worked in autonomous motorbikes, boats, and cars. The link is in the description below. I hope that you have enjoyed this video and learned about the awesome world of self-driving cars. If so, please consider liking and subscribing, especially if you want to keep current with the bleeding edge of artificial intelligence. Until the next one.